Very good evening, Lakshmi. How are you? Very good evening, Meera. Good evening, sir. Let's wait for some time, then we're going to start with the class, okay? Okay, I will wait. So in the previous class, we just started with the carboxylic acid, ketone, and this chapter is aldehyde one. There we're discussing about like these are the slides. Just go through for this. Look at this. That we just started with like what is carbonyl compound. So the group which one has a carbon double bond oxygen kind of bond. So this is a carbonyl compound. Okay, we have to classify this into the two part. One is the aliphatic system. One is the aromatic system, like the previous one. Okay, and then we further classified into the two part, that is a class number one, when this position is not replaced by any kind of nucleophile. Okay, any nucleophile is not going to replace this position. But on the other hand, the class number two, where we're having a class number two, like let's suppose the carboxylic acid or the OR or the NH2 group or X or like anhydride. So in these cases, like it's very easy to replace these OH or 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 NH2 group with some substituent. Okay, then we're discussing about the use of the carboxylic acid in our day-to-day life. For example, like the first picture represent, it's nothing, it's our HCHO, that is a formaldehyde, and it's a very good you can say it's used for the preservation of the that which one, fossils. Okay, and then penicillin, it's a very good antibiotic, and then bloodhound is there. Every person has a different body order just because the ketone and aldehyde is there, and then some aldehyde or ketone also present in our retinal there, and then this is the cinnamon, cinnamaldehyde. Okay, and then vanilla, that vanillin. So structure is really important here. Then we do very sweet flour. Okay, maybe you already know. And then we're discussing about the nomenclature part. There we discuss about IUPAC nomenclature. IUPAC one you already covered. So the main topic of discussion was the common name. So there's some common name we discussed there. That's it. This is the all for the previous class. Okay, Mira. Very good evening, Niharika. Okay, and like for the very detail, you have to check it for the previous class. So right, you can say it's not that much important right now. Okay, so just basic part we covered there. Okay, Mira. So let's start with, I guess everyone join now. So thank you so much for joining, but please make sure from the next time. Okay, little bit be on time. Okay, because already I guess 5 minutes. So please, it's a request to everyone. Okay then, so let's continue what we are discussing there. So basically in the previous class we wrap up about the IUPAC name and a common name there. Okay. So now in today's class, the first topic of discussion is going to be the structure. Okay. That is the structure of carbonyl compound. Okay, normal we I'm not saying carboxylic acid, I'm not saying aldehyde, that is normally simply that carbonyl compound. Like how about the structure there, okay? So carbonyl compound. Anyone, my first question to you, the point number one in the structure, that how about the hybridization? Yes, please, anyone. What is the hybridization of the Cu group? Let me just write what I want to ask there. So Cu means this is the Cu group there, okay? So any group can be there, but important is what Cu there. So in this case, obviously this is a double bonded carbon, so it is going to be the sp2 hybridized. If this is sp2 hybridized, so definitely the structure should be planar in nature. Okay, if the like structure is planar in nature, so better to write like this, And then we can say the angle is what? The bond angle is 120 degree there, okay? So this is normal structure we know. Yes, sp2, you're right, okay? So this normal structure we know about the carbon. This is not a, you can say not very difficult thing. We already know this. So that's it. This much thing is important here. Now let's solve a question, okay? So it's a PYQ. Very simple question. Just try to answer the question. So question will like assertion said, that formaldehyde. It's very easy, okay? Formaldehyde is a planar molecule. And the statement said or the reason said it contains sp2 hybridized carbon. So like option number one, both are correct, and the reason is the correct explanation about the assertion. Then both are correct, but not reason is not explaining properly. Option C is correct, B is not correct. C said that is assertion is incorrect or reason is correct. Okay then. So what do you think about this? Yes, please. Okay, Meena. But you know, sometimes this is the problem because we used to think every time the option will be like this. But sometimes they can change the option, so be noted, okay? Okay, very good. Easy question, right? So option one said that formaldehyde, right? You know what is formaldehyde? This is the formaldehyde. Okay, wait. So what is the formaldehyde? This is the formaldehyde. And if this is the formaldehyde, and then what is the reason behind the planarity? Obviously sp2 hybridized because trigonal planar is the structure there, okay? So that's it. This is all for the structure, name and everything. Now let's start the real part. That means important one means preparation part. So in today's class, the important topic which we are going to start is the preparation part there, like how to prepare this. So preparation you can say. So in the preparation part, let me just kind of make a kind of chart for you, and then we will cover about it. Okay. So the point number one, first of all, we are going to discuss about aldehyde and ketone simultaneously, right? Because sometime maybe you already know if you're using alcohol and if you're using oxidizing agent, so end up with aldehyde and ketone both there. Okay. So that's why that first of all we're going to discuss about aldehyde and ketone. Okay, simultaneously you can say both. Okay, then the second topic is only for aldehyde. Okay, so you can say only aldehyde. And the third one, that third type of preparation, that is obviously ketone only. Okay, so three part we are going to cover. So let's just start with the preparation part. And anyone, any method of preparation, you know how to form the aldehyde or ketone from the previous classes because we already covered this thing so many times. If you know, okay, don't worry, I will explain. But I want to check one thing, like you know or not. Okay, let me just write the method name. Okay, so what is the method name? That by oxidation of alcohol. Okay, by oxidation of alcohol. So let me just give you a quick brief quickly that what we discussed in this part in the previous class, that if you are having a kind of alcohol, okay, so in this case, if we are using a kind of oxidizing agent, okay, if you're using oxidizing agent here, so what we are end up there, that is first of all we are end up with aldehyde. Further, that the second step is going to be the that acid there. So it means if you want to stop the reaction till aldehyde or ketone is not the issue there, so yeah, you have to use simply a mild oxidizing agent. And we already covered very good mild oxidizing in every kind of like reagent in the alkyl phenol chapter, if you remember. There we're discussing about the chemical property, right? So yes, please, anyone, at just a single, only one reagent, you know. If you want to stop the reaction till aldehyde, any reagent. Okay, very good answer. Like control oxidation. But I am asking what a reagent, okay? So I already told you, like if you are using a mild oxidizing agent, so the reaction stop till aldehyde only, right? But Any reagent. CrO3. Okay. No, you can't say CrO3. Okay, you have to mention this dry CrO3 because if little bit acid present in a CrO3, so that become a very strong oxidizing agent. Okay, Niharika, so although you're right that you have to use CrO3 directly, okay, but the important is what dry one. We can't use acid because that then become a Jones reagent and that going to be the strong acid there. So dry CrO3, so the very first reagent we can use. Second off, one more famous one if you remember, the kind of famous, remember? PCC, right? I only told you that it's going to be the important part. So PCC, copper, yes, very good. So you can use PCC. And one more, that is a copper. How about the temperature there? 573 Kelvin. Or that is a 300 degrees Celsius. So both we cover already. Three reasons we only covered in very much detail there. So what is the good point about? Just only the IUPAC Dashika, okay? Just only the IUPAC. So in the preparation part basically started in today's class only Dashika. Okay, so yes, pyridine, yes, you're right. That what is the PCC? That is a pyridium chromium chloride is there, right? So we already covered, right? So let me just write a kind of table for you, like how to end up with this. So let me just first write about the PCC there. If I am using PCC as a reason, I'm not going to explain it's very detailed what is PCC because now you already know. Even we already covered about a little bit kind of mechanism as well. Okay, so just be noted what is happening if you are using a primary alcohol. If you're using a primary alcohol and if I'm using PCC, so in this case, what is happening that we are end up with the aldehyde. Aldehyde. If you're using a secondary alcohol, then what we are getting there, if you're using a PCC similar, so what we're getting there, that is a simple ketone there. If you're using tertiary alcohol, so be noted with PCC reaction is never ever be there. For example, let's just discuss about the example part as well. Okay, first of all, for this one, if let's suppose I'm using a kind of that alcohol, let's see the example CH3, COH, and this. Okay, so what is it? So the name wise, what is it? It's going to be the 1, 2, 3, 4. Okay, one more hydrogen is there. So it's our ethanol there. So if you are using ethanol and if I'm using PCC as a reagent, and definitely it's a primary alcohol. Okay, so what we're getting in this case, that aldehyde. And what is the common name for this one? Very good in Batul and Mayak. Oh, Mayak, after so many days. Yes, please. What is the common name for the CH3COH? We already covered common name. Hmm? Okay then. So I'm assuming then it's going to be the acetaldehyde. Okay. So it's a acetaldehyde. Okay, sorted. Now let's see the next one. That if you're using it, the secondary alcohol there, what if, okay. Let's suppose we are using now, it's a OH hydrogen and a CH3. So it's a secondary alcohol. In this case, same, if I'm using PCC there, so what we are end up there, we are going to get ketone. Okay, CuCH3. Or the common name, it's a acetone there. Okay, this is all for the PCC. Let's go for the next reason. The next is going to be the copper one. Copper, and the temperature is what? 573 Kelvin, or you can say 300 degrees Celsius. For this one again, the topic of discussion right now is the ketone and aldehyde. So again, if you're using a primary alcohol, we are getting again aldehyde. Okay, if you're using secondary alcohol, so if you're using a secondary alcohol, we are getting a ketone there. And for the tertiary alcohol, you will tell me what we are going to get here. Yes, please. It's a kind of exception if you remember. Of course, but the today's class is just the preparation part. In the previous class, we discussed about the basic point, that what is carboxylic acid or what is carbonyl, and then how to classify them, and then the nomenclature part. Okay, but so the main thing actually starts from the today's session. So you can continue. Okay. Yes, please. How about the tertiary one? I hope you remember I already highlighted to you there that it's very difficult for tertiary alcohol to react. Okay, alkane, very good, Mayank. Okay, no, Media, we can't get the acetone here. So if you are having a tertiary alcohol, okay, so be noted in this case there is a no hydrogen is present for reduction. Then how we can say, okay, sorry for the oxidation. Then how we can say? So I already told you earlier that this is the exception case where we are getting an alkene there. Okay, means how about the case here? If let's suppose this is a kind of alcohol, it is a tertiary alcohol. So in this case, if let's suppose you are using copper, okay, if it is mentioned you are using a copper and 573 Kelvin is the temperature there, so definitely we are getting a double bond. And what is it? It's a isobutyl. Okay, it's a isobutylene. Okay, that's it. Okay then, so that's it. This is all for the copper. Now the next one. Let's start with the second preparation. That is the preparation via oxidation part done. Hydrocarbons. So from hydrocarbons. So the method number one, that and by oxidation. Next method is what? From hydrocarbon part. So like if I'm using this word hydrocarbon, so be noted hydrocarbon doesn't mean we have to use only alkane there. So hydrocarbon means that you can use double bond, you can use triple bond as well. Okay, so any method, do you know about this? Let's suppose you are having a carbon-carbon double bond. Just think about it, and I want this. Any method, you know already. Now, of course, Mayank, now we can continue with the live session because right now carboxylic acid is going on. Okay, so it is a very much important chapter out of all the session right now. Okay, but of course, some topic we are going to use from the previous classes. But if you miss, like you said, last lecture of the previous chapter on the second last. No, second last we are not going to use. Yes, please. Any method. Do you know if you are having a double bond or a multiple kind of bond and I want this? Very good. Yes, that and you're right, it's going to be the ozonolysis. Okay. So next point. Any kind of ozonolysis. So yeah, you're right. Let me just write the reaction. What is ozonolysis? Don't worry, I will give the brief as well. So let's just talk about the method number one, that is ozonolysis. Okay, the method name is what? Ozonolysis. As the name suggests, obviously we are going to use the ozone there. So let's see how the reaction is going to happen there. Again, now we are in 12th class, so don't worry about the mechanism. The mechanism only for the 11th class there. So you are having some kind of carbon-carbon double bond. This is a general mechanism. Okay, general mechanism. So in this case, you will be having a some kind of carbon-carbon double bond. We are using ozone. Let's see how it is going to work. So this is a, oh wait. This is the ozone. This is how the ozone look like. There's a positive charge and there's a negative charge. Or you can simply use the dative bond as well, okay? So let's see how the bond breaking. This double bond simply break here and this double bond attack here. So that in this case, this is a carbon single bond. First of all, this kind of structure we are end up. Okay, it's a kind of addition reaction that ozone simply added on a carbon-carbon double bond and then it's further rearranged. Okay, actually no space, so that's why. Look at this, carbon carbon and then there is a formation of house kind of structure. Okay, so we used to remember like house in the, when we are a child, we used to form this kind of house like this. Anyway, I guess you're getting. So this is the house kind of structure and this is known as a ozonite. Okay, so this is known as a ozonite. So it's a kind of intermediate during the ozonolysis process there, ozonite. Now it's going to break simply, then this is how it's break. Okay, so let's just understand this point on the next slide. So you're having a carbon, and this is how oxygen is there. Look at this. Okay, so here we are discussing about the reductive ozonolysis, be noted, because with reductive ozonolysis only, okay, we are end up with the aldehyde. I will tell you what is reductive and oxidative. Wait for a while. Okay, so what is the reason you're using ozone plus that is ZNO? Okay, so this is the extra point here, and obviously the water or for the hydrolysis we are going to use as well. So in this case, what is happening? Then zinc came into the picture. This bond is going to break. Zinc is combined with the oxygen, and what we are getting that this is some carbon and a double bond form here. Okay, so like it's in this case, I'm taking some symmetrical molecules, so 2 mole of this, and then ZNO form there simply. Okay, so this is how the mechanism. Again, mechanism is not important. Simple. How the reaction is going on is the important part here. Ozonide, look at this, and I guess you already know the shortcut. That simply break the double bond and just put the oxygen there. So first of all, let's discuss about the ozonolysis part. Ozonolysis classified into the two part. That one is the oxidative ozonolysis and one is the reductive ozonolysis. So what is happening in the oxidative ozonolysis? Ozone is the common point in both the cases. Here you are using directly the water there. Here you have to use some kind of ZNO and then water there. So zinc is just for we are using zinc just for controlling the reaction, okay? And then that sometime maybe ozone and you can use H2O2. H2O2 can be there, okay? In this case, if you're using that oxygen and this kind of molecule is there, SH2 kind, means sulfur. Sulfur is again behave like a little bit kind of poison, means sulfur every time, most of the time, if you remember that the Lindlar catalyst, there we're using sulfur as a poison. So sulfur main motto is what? Just to reduce the rate of a reaction. So any sulfur compound you can use. But most famous one, like this is the famous one or this is the famous one for your, you can say level. So that's it. Now, important is what? In this case, if let's suppose you are having a carbon-carbon double bond, and let me just connect some kind of hydrogen like this. Okay, let's suppose this is a CH3 and this is a hydrogen as well. So in this case, if you are using oxidative ozonolysis, what does the trick? Break this double bond. Okay, and we are getting that it's a CH3 and a CH. We are assuming reaction have to be stopped till here, but since this is oxidative ozonolysis, so don't at the end we are end up with this means acid. This is the problem. Oxidative ozonolysis is vigorous. The reaction is never ever stopped till aldehyde. At the end, acid formation always take place. But what is the reductive ozonolysis there? So in the reductive ozonolysis part, the reaction stop till aldehyde only. Again, ketone is not the issue. Only what is the issue? That is aldehyde. Okay, this is simple, the ozonolysis part. Now let's solve a question. Okay, so just try to answer the question. It's very simple question. Easy one. Just answer the question. Okay, let me just write the statement. There is a some P present, okay? So what will be the formula for this P? It is C6H10, okay? Yes. In this case, the reason number one I'm using is the diluted H2SO4, okay? And HZSO4. Okay, wait. Diluted H2SO4. Although we have to cover this reaction just in a while, but let me tell you, if you're using HgSO4, if you remember the oxymercuration, demercuration, so what is the use of the Hg? Hg just important for the concentrated kind of mechanism. It means that, for example, let me tell you how. If let's suppose I'm having a carbon-carbon triple bond and we will be having Hg, so like that one attack here, one be like. So in this case, that the concentrated kind of mechanism followed here. That's it. Otherwise, simple. If you're using diluted H2SO4, I hope you already know what is the meaning of diluted H2SO4. There is some carbon-carbon double bond. Let's say if you're using water, there's a little bit diluted H2SO4 if you're using. So what is happening? OH ion and H positive ion is going to add, and we are going to follow the Marconi equation. Okay, so this is the topic of the previous class. Anyway, let's continue again. So the reason number one, we're using this diluted HgHO4 and that Hz. This is the reason number one. And the reason number two, we are going to use. NaBH4. What is this? Again, we already covered in the previous class. What is it? It's a very good reducing agent. Okay, I hope you already know the function of lithium aluminum hydroxide and the sodium borohydride and dibyl H. We already covered this topic, right? So it's a reducing agent. It's a very good reducing agent. And there is some Q form. Some P we have to start, and there is some Q form there. Okay, next point, that this is some Q, and in this Q, what we are adding them. Okay, so this is a Q. In this Q, we are using diluted H2SO4 again. Okay, don't worry, I will give you the option as well. So second one, we are using ozone. Third one, we are using Zn and water there. Okay, so I hope you're getting that. Why? What is the meaning of this? It's representing oxidative ozonolysis. Okay, so at the end we are end with this product. So maybe you already know what I want to ask to you now. What is the P and Q? What is P and Q? Okay, so options are given. First, everyone try to analyze the question. Okay, 1 minute for you, or like 1 minute, not 30 second. Then on the next slide, I will write some option for you, like what is the P and what is the Q according to you. Okay, so just please analyze this. Voice is not okay. Is the same problem with everyone? Yes, please, anyone confirm the voice problem with everyone? Yes. Then how it can you resolve? Because right now I'm not using any kind of platform, little bit. But why? Wait, okay, I have to wait, okay. Now please. Yes, it's okay now. Okay, clear. Okay. Okay, Shiva. Okay, done. I hope you're done with the question, right? So let me write the option for you. So you have to identify what is Q and what is this P, okay? So options are that like option number A. So the P is, and then Q, okay? I have to check like what is P, right? Oh, I'm sorry. This is Q and this is P. Option number B. P is, and Q is, option number C. P is, Q is. And option D, none of these, okay, because there's a no space left. Yes, please, answer the question. Okay, Lakshmi, I guess I already changed now. Not an issue if some option is not going to match even a single option, so none of these is also present, right, Lakshmi? So answer, just try to solve. You are right, although. Okay, just wait, I have to change Q, Q and PP, okay? I'm taking this as a P and this is a Q, okay? First solve this question, okay? Oh, of course, I'm sorry. Where I have to put? Okay, let me just remove from the screen, okay? I hope it's okay. You can solve this question just by counting the number of carbon as well. Means at least eliminate some options. No, actually be smart, okay? It's not like I'm giving the answer, but be smart when you're solving the question. Sometimes no need to even solve the question. Okay? You have to identify P and Q. I'm sorry, Dashika, then. This is the question, okay? If you don't know the question. Okay, Batula. A, B. Okay, can I, if you're able, okay, I guess it's okay now. Okay? I was checking this. Is you want to know me? Ah, of course, why? You already smart, right? Every time the classman like I took the option first, right? And every time you're wrong. Anyway, good one. Okay, I guess it's enough time, right? So let me just explain the question. But before starting with the question, do you know if you are able to approach? So very good, everyone. This is advanced question. Okay, so it's advanced question but not difficult question. So let's start with like what is P, what is Q. Okay, so first of all we are given with the C6 and H10, right? So let me just search that P, okay, and how many carbon, like one carbon, two, three, four, five, six. Okay, one, two, three, four, five, six, seven carbon, wrong. Okay, one, two, three, four, five, six, seven carbon, wrong. Okay, so it means we are just left with two options, that is none of these. Okay, it's not like you have to ignore this option, sometime none of these can be the answer as well. Okay, so you can say option number A or option number D can be the answer. Okay, although the space is not there, otherwise I have to write the D option as well, right? So okay, sorted. But like, how to start with the P, okay? And like on which basis you are saying this is a Q there. So let's just start with the carbon or the structure there. So let me just write the structure here, then how to approach. One carbon, two carbon, and three carbon total, right? This is a structure which we are given here. And in this case, first of all, we are using H2SO4, right? At the HgSO4. What is the only main agent of the HgSO4? Just to increase the rate of reaction, we are using HgSO4. Okay, the simple we are adding here, if diluted H2SO4 diluted acid is written, it means you have to make sure we are going to do what, that addition of water simply. So if you are going to add the water, it means we are having OH ion and H positive ion, and after this what we are going to do the next step, that Marconic addition we are going to follow. Okay, so according to the MV rule, Marconic of addition, the negative part of the adding molecule or the addendum is going to connect with that carbon where we are having less number of hydrogen. So how many hydrogen is there? Zero hydrogen. How many hydrogen there? One hydrogen. So definitely the OH going to connect what or with which carbon? That the carbon has a less number of hydrogen. Okay then, good one. So you can say means that the double bond is there. Okay, because we are adding only one OH, you can say. Okay, so like this. And in this case, the next one is this OH and hydrogen is there. And then it's a CH3, it's a CH3, and it is a CH3 again. 1, 2, okay, 4. So this is the thing which we are getting from here. CH2, let me just write. Okay, this one. But this is the reason number one. Let me just back again. This is the thing which we are getting only for step number one. Okay, step number one. Now, as we know that logically, the what is it? It's a enol form. Yes, in this case, we are having a choice. For example, if this is a carbon and it's a like a three carbon is connected like this, and this is a OH and a double bond carbon. So it's a enol form, and we are having a choice. I hope you already know what is the next step there. That one, two, and three. It's a 1, 3. It's a trial to kind of tautomerism. So in this case, tautomerism take place. If you don't know the tautomerism, so again watch the hydrocarbon or the GOC part of the 11th class. So in this case, keto-enol tautomerism going to take place. So tautomerism is there. Means the double bond or the ketone formation take place like this. Okay, this is the thing we are getting. This is the step number one, the reason number one. After this, we are adding the second agent, that is the NaBH4, and NaBH4 is a reducing agent. So what is the use of that NaBH4 there? That if you are having a carbon 3, okay, just connect 3 CH3. And this is a CO and a CH3 there. And in this case, if I am using NaBH4, it's a reducing agent. Okay, so what is happening? That whatever be the carbon, it is connected with the C, and this is a CH3 and this. So what is this? What we really want, this is that Q. So let's just check whether we are right or not. Look at this is the Q there. Okay, although like our job is done, but what if like how we are getting this thing? Okay, so in this Q now we are going to add diluted H2SO4. Okay, so again in this case, after we are getting this, I'm going to use again that is diluted H2SO4. So if I'm using diluted H2SO4, can anyone tell me what is the next step? Means which kind of reaction we are going to follow now? Okay, Vaibhav, but पिछला means the first step is not clear, right? I will explain. एक मिनट के लिए वेट करना आप, ठीक है? आपको मैं हिंदी में समझा दूंगी, रुको एक मिनट आप. Okay, Dashika, how to find? So, like for this one, you will be having a very good knowledge of it, tautomerism. So, we are going to check it for like whether the first thing alpha hydrogen have to be there. Second of what, that sp3 alpha carbon have to be there. Okay, just wait. I will give you a kind of brief. Okay. So in this case, yes, we are going to follow the substitution. Mayank, it's a Dehydration reaction, removal of water. Come on, we already covered. I guess it's third or fourth time we are discussing about this reaction. That this is H positive, oxygen has a lone pair attack here. This is a very good living, and then double bond formation there, right? So in this case, what we are getting then, that is it's a CH3, okay, CH3, and I hope you know we are going to follow the elimination here. And which kind of elimination we are going to follow here? That is alpha and beta. So this is my alpha carbon, this is my beta carbon. Don't consider this side because there's a no beta carb hydrogen is present. Okay, the normal basic reaction mechanism we are going to apply. So simple, that water molecule release and we're getting carbon carbon double bond and a CH2 there. Okay, so this is the thing which we are end up in the case number one. Okay, so it's a point number one. But if you are observing toward the mechanism, ma'am, see the questions that you are going to follow the ozonolysis and we are getting acetone. But ma'am, if you are breaking this, we are end up with something different product here. Then how to get that? Any kind of idea? Okay, wait. I will explain every part. Okay, if you are left at some point. Okay, Dishika, let me just finish the question. Yes, please. So let me tell you one thing that we discussed this thing so many times that in this case, first of all, that if you're observing, wait, I will tell you how. So the step number one, what is going to happen there? That H positive oxygen lone pair attack on a hydrogen. Okay, so what we are end up there that we are getting it's a C. Okay, CH3 and a CH3 and a CH3 simply. Okay, and then carbon OH is there. It means water formation kind of thing. It's going to remove. Okay, so I'm just simply removing this once this form. Okay, and there's a positive charge generated. So this is not a stable carbocation. It means in this question we are going to follow the rearrangement. Okay, rearrangement we are going to follow. So look at this with respect to this. What is the one and two? We are going to follow one, two, methyl shift. Methyl shift. Okay, methyl shift we are going to follow there. It means that after the methyl shift what is happening, that carbon carbon, so the 2 CH3 group connected here and a 2 CH3 group connected here. Okay, and then 2 CH3 here, 2 CH3 here, and now the positive charge is there, and simply that the next step is what, removal of hydrogen there. Okay, so after this the removal of hydrogen, let me just write the same thing here, double bond we are end up. And once we are end up with a double bond, just go with the ozonolysis. And if you to go with the ozonolysis, look at this, break this bond, and we are getting 2 mole of acetone molecule, and this is the final answer. Okay, so the question part is clear. I know, Dishika, you are not able to understand. Okay, ma'am, it is possible to break a bond group itself. No, okay, it's not possible technically. First, everyone, like apart from Dashika and Weber, any problem you are having with the mechanism, all that I'm going to explain one more time, right? But this time I'm going to explain in Hindi. Okay, so that if you are okay, just let me know. Don't worry, Dashika. Okay. So let's discuss about this mechanism one more time, everyone. Okay. So yes, वैभव and Dashika, देखो बात कुछ ऐसी है, आप मेरी बात ध्यान से सुनिए. क्या है हमारे पास? सबसे पहले we are given with C6NH10. So do you know Hindi, Dashika? Just let me know. Okay. So I have to consider. Where is my video? Okay, so let's continue again what we're discussing. You are given with the C6 and H10, okay? So in the given options, okay? So let me just back again the question part. You are given with some P. Okay, you are given with some P and this is my P. C6H10, this is given as a P. So out of all the options, if you have to count, मतलब अगर आप यहाँ पे चेक करोगे, सो सी दिस, यहाँ पे एक कार्बन, दो कार्बन, तीन, चार, पाँच और छः, टोटल 6 कार्बन प्रेजेंट है, राइट? सो लुक एट दिस, बट यहाँ पर अगर आप देखोगे यहाँ पे 7 and 7 है, मीन्स इन दोनों के केसेस में 7 कार्बन है हमारे पास. जस्ट बाय यूजिंग दिस मेथड कि दोनों के पास मतलब 7 कार्बन है और एक के पास सिर्फ 6 है, तो हमने पी को मार्क कर दिया, राइट? बट अब क्वेश्चन आता है कि मैंने क्यू को ही क्यों सेलेक्ट किया, ठीक है? तो चलो स्टार्ट करते हैं। सबसे पहले हमें कोई C6 and H10 दिया था। ओके, मैंने इसमें पहला जो रीजेंट डाला है वो है डाइल्यूटेड H2SO4। तो बच्चों बात कुछ ऐसी है, जब हमारे पास डाइल्यूटेड H2SO4 लिखा होता है ना, तो इसका मतलब होता है कि हमें सिर्फ पानी ही ऐड करना है। ठीक है, और यहाँ पे जो HgSO4 यूज किया है उसका सिर्फ इतना सा मतलब है कि रिएक्शन का जो रेट है वो बढ़ चुका है। ठीक है, हम करेंगे, दिस इज द वन मोर नेमिंग रिएक्शन, दैट इज अ कुचिरो रिएक्शन। ठीक है, तो देखो मतलब जो हमने वहां से पी सेलेक्ट किया ऑप्शंस में से, ये हमारा पी बना, मतलब अकॉर्डिंग टू द ऑप्शंस। ठीक है, तो ये इस दिस इज द CH3, दिस इज द CH3 एंड दिस इज द CH3। अब जब जब यहाँ पे डाइल्यूटेड H2SO4 डालोगे, मतलब हमें ऐड करना है पानी को। इट मीन्स द वाटर मॉलिक्यूल वी आर गोइंग टू ऐड, तो यहाँ पे हमने ये लिया। ठीक है, अब यहाँ पे हम लगाएंगे मार्कोनिक एडिशन। अकॉर्डिंग टू द मार्कोनिक एडिशन क्या होता है कि जो कार्बन किस जिसके पास कम हाइड्रोजन है, जैसे यहाँ पे 0 हाइड्रोजन है और यहाँ पे 1 हाइड्रोजन है, तो OH इसके सॉरी सॉरी नॉट दिस वन, यहाँ पे बात करें ना, आई एम सॉरी फॉर दिस। तो देखो यहाँ पे 0 हाइड्रोजन है, ठीक है, और यहाँ पे 1 हाइड्रोजन है, तो OH इस वाले के पास गया। ठीक है, द नेक्स्ट पॉइंट इज व्हाट, हमें यहाँ पे क्या देखने को मिलेगा फिर, कि अगर आपके पास ये कार्बन है तो द OH ग्रुप इज गोइंग टू कनेक्ट है। सबसे पहले OH यहाँ पे कनेक्ट हो चुका है। ठीक है, सो दिस इज हाउ वी आर गेटिंग द थिंग विच वी आर चेकिंग, ये हमारा जो है वो क्यू बन गया। ठीक है, मतलब सॉरी, ये हमारा जो हमें चाहिए था, जो पहला रीजन डाला इससे बना है। तो दिस इज व्हाट, ये हमारी इनॉल फॉर्म है। ठीक है, तो यहाँ पे मैंने अप्लाई किया कीटोनॉल टॉटोमेरिज्म। अगर आपको नहीं पता है तो व्हाट इज द कीटोन इनॉल टॉटोमेरिज्म, आपके पास एक इनॉल फॉर्म होता है या कीटो फॉर्म होगा। ठीक है, यहाँ पे फिर क्या होता है, इफ लेट मी जस्ट काउंट द नंबरिंग, एक कार्बन, दो कार्बन, ठीक है, और लेट जस्ट राइट, ये CH2 और ये हाइड्रोजन है। तो ये जो ये वाला ऑक्सीजन है, ये कैसे होगा रिएक्शन। ठीक है, देखो ये सिर्फ मैं पोजीशन चेंज करूंगी, ठीक है, हम ज्यादा मैकेनिज्म में नहीं जा रहे। तो यहाँ से स्टार्ट करिए, 1 कार्बन, 2 कार्बन एंड 3 कार्बन। ठीक है, तीन के मतलब 3 एटम के साथ में होती है ये ऐसी तरीके से। तो यू कैन से हाइड्रोजन यहाँ पे चला गया। सी दिस, होगा क्या, यहाँ पे बीच में डबल बॉन्ड आ जाता है एंड द OH, ये देखो यहाँ से हाइड्रोजन, ये हाइड्रोजन रिप्लेस करके यहाँ पे ऑक्सीजन पे जाके कनेक्ट हो चुका है। ठीक है, तो दिस इज वी आर गेटिंग नाउ। एंड देन उसके बाद दिस इज अ CH2, तो यहाँ पे ये CH2 होगा एंड दिस हाइड्रोजन इज कनेक्टेड, तो इसको हम बोलते हैं कीटो फॉर्म और इसको बोला जाता है इनॉल फॉर्म। अगर हम कंपेयर करें तो कीटो फॉर्म ज्यादा स्टेबल होती है इनॉल फॉर्म से। ठीक है, तो बस यहाँ पे हमने यही किया है कि इनोल फॉर्म स्टेबल नहीं है, तो मैंने इसको कीटो फॉर्म में कन्वर्ट कर दिया। ठीक है, तो व्हेन यू आर कन्वर्टिंग दिस इज इनटू द कीटो फॉर्म, ठीक है, मैं यहाँ पे लिख देती हूँ। तो देन हाउ, ये हमारा CH3 है, ये हमारा CH3 और ये भी CH3 है। एंड देन उसके बाद क्या होगा, ये डबल बॉन्ड ऐसे बन चुका है। तो ये जो हमारा पहले रीजन से सिर्फ इतना आया है, हमने इनोल को कीटो में कन्वर्ट कर दिया। ठीक है, अब जब मैं इसी में डालूंगी रिड्यूसिंग एजेंट दैट इज NaBH4, ठीक है, अगर आपको नहीं समझ आ रहा तो मतलब आपने अल्कोहल फिनोल को अच्छे से नहीं पढ़ा हुआ है। ठीक है, तो उसके बाद क्या होगा कि जो ये O था ना, जो ये वाला बॉन्ड, ये OH में कन्वर्ट हो चुका है। ठीक है, यहाँ तक समझ आया वैभव, स्टेप नंबर 1। ठीक है, ओके, नो नो शिवा, नॉट एन इशू इफ यू आर एबल टू अंडरस्टैंड इंग्लिश। जस्ट मैं दो लोगों के लिए, आई एम जस्ट एक्सप्लेनिंग ओनली फॉर द टू पीपल्स लाइक दशिका एंड वैभव। ओके, तो इट्स नॉट लाइक शिवा, डोंट वरी, आई हैव टू एक्सप्लेन इन इंग्लिश ओनली। ओके, आर यू गेटिंग नाउ वैभव? ठीक है, एंड दशिका, कि क्या हुआ, कि हुआ क्या, मतलब P and Q क्या होते हैं। एंड उसके बाद हमने इसको कन्वर्ट किया, फिर दोबारा से रीजन डाला, देन डन। ठीक है, तो आई होप इट्स क्लियर नाउ, बटूला। So you're watching web series and then Hindi. Oh. So that's it. Let's continue again what we're discussing. So I hope the ozone layer part is now clear for everyone. Clear, crystal clear, right? So let's discuss about the second preparation. Preparation number two. Okay, wait. Let's back again what we are discussing. So this part is done. And the second one is what? Sorry, that hydration of alkyne. Okay, although the hydration part we just discovered that Kuchiro reaction the same. Anyway, let me just explain. So it's a hydration. Okay, can you just tell me what is the meaning of this word hydration? Hydration of alkyne. Yes, please. Oh, yes, please. What is the hydration of alkyne? When you add water into the carbon-carbon triple bond, right? So let's just again discussing about what is it this. So you are having some kind of carbon-carbon triple bond, right? Oh, sorry then, because we can't represent the CH3 bond be like this. Okay, this is a carbon-carbon triple bond. And in this case, we have to use directly the water. So let's try to understand my point that why we are using HCSO4 in that example as well. Okay, although if you already watched the oxymercuration demercuration part, maybe this point already you know. But let me tell you actually what is happening. That in the solution you are having OH ion, okay, and in the solution you are having H positive ion as well. So first of all, the step number one, what we are going to follow, that is this carbon-carbon triple bond attack on H positive, and then you are getting a carbon-carbon double bond, and then H positive connected sorted now, and then there is a direct carbon have a plus charge. So what is the problem with the direct addition of water into the carbon-carbon triple bond? That the reaction follow the formation of carbocation, and this carbocation is sp2 hybridized, and it's highly unstable. It's not stable. It's highly unstable molecule there. So then we want to increase the yield. Okay, if you have to check it for the graph, do you know what is happening? That if let's suppose you are starting with carbon-carbon triple bond, so the rate of reaction is very much high because the graph be like I can't go with there's a carbon-carbon double bond and then positive charge. No, I can't go there. So means what is the issue there? We have to resolve the problem. Then HGSO4 be like, don't worry, I will solve the problem. So in this case, we are using HGSO4 so that you have to simply increase the rate of a reaction. So let me tell you the mechanism. Although it's not a kind of mechanism, just try to understand the basic criteria. So you will be having a some carbon-carbon triple bond and then Hg. You know in HgSO4, Hg present in plus 2 oxidation state, okay? So the one triple bond attacking on Hg, the one part of Hg taking here. So in this case, what is the issue with the mechanism? That the direct positive charge on a carbon, and in this case see the beauty here, look at this, we are just left with the carbon carbon double bond. Hg is now connecting like a cyclic thing. Okay, so now Hg has a positive charge, you know very well, right? Partial positive charge, and then that OH came into the picture. So after that, that OH attack now. So in the previous one, what is the problem? That in this case, it's a like simultaneous mechanism. OH just connect, okay, and Hg leave the molecule. So see this, in this case, what will be the next step there? That if you are using this point, then what we're getting, carbon, double bond, and Hg part simply connected here now. Okay, and OH part connected here, and the second one we have to undergo again the hydrolysis part, and then what is happening there? That Hg molecule remove. Okay, so it's a carbon-carbon double bond and hydrogen and OH. So this is the thing which that's why we're using HgSO4 here. And do you know the name of the reaction? The if you are using, let me just write the general mechanism. Okay, sorry, general reaction. So how about the general reaction there? If you are using some R, carbon triple bond carbon, okay, like this, or it's not like terminal or isolated, any alkyne system you can use. Okay, and in this case if I'm using H2SO4 and B noted, it's written dilute H2SO4 or HgSO4. So what we're getting basically that R, carbon, double bond, and a OH and a hydrogen, simply like this, and then it's further going to convert into the keto form there. That's the thing which we are going to remember from here, understand from here, that the final product is not the alcohol, because basically what we're discussing preparation part. So what is it? It's a ketone or aldehyde. It's totally depend upon the situation. Oh, I'm in this case, what it is this? It's nothing. It's a ketone simply. It's a ketone we are end up. Ketone formation. Okay. So what is the name of the reaction? So it's a naming reaction, important reaction. So what is the name of the reaction? It's a Kucherov reaction. Let me just write the name properly. So it's a Kucherov reaction. Okay, so this is the name of the reaction, Kucherov reaction. Important, with water we have to use little bit amount of HCSO4. And the question part we already covered, right? So it's not a big deal, I guess now. That's it. This is all for the Kucherov reaction or the preparation from the hydrocarbon. Okay, now let's start with the next one. Next preparation, okay? So the next preparation is what? Wait. How to follow the sequence. Okay, next oxidizing agent. This is really important oxidizing agent. Do you know it's a that much strong like the KMnO4. So oxidation by HiO3 molecule. Okay, first of all, try to understand the mechanism, like how to use this HiO4. Because right now, this is not the important one, but in a biochemistry, the HiO4 play a very much important role. It's a very strong oxidizing agent. Okay, if you're checking for the oxidation state for iodine, it is going to be the +7. Okay, so it's at the like maximum oxidation state of the halocene family, especially. Okay, so what is the general reaction? So generally, if we are talking about the general reaction, so generally, what we are going to use in this case, we are going to use the diols. Okay, so which kind of diol these are, like optional geminal, vicinal, or allyl? That means this is the case. HiO4. So the same thing I'm using, Shiva. Vicinal. Okay. Okay, maybe my O is not look very good for you, but it's iodine. Okay, let me just write properly. It's a hydrogen, iodine, and O4. Okay, so +7 is the oxidation state. Yes, very good, everyone. This is vicinal diol. Okay, it's a vicinal diol simply. Now, in this case, if I'm using this HiO4 is there, so what we are end up there basically, so we are end up with that this bond break. Okay, don't worry, I will tell you how the thing look like. Just wait for a while. And plus a carbon-carbon double bond. Okay, so now the question will be like it may be aldehyde or it may be ketone. I will tell you how that I said aldehyde or ketone. For example, let's start with the kind of question. Okay, so example you can say. So let's discuss about example. I guess it's not going to be the visible one. Okay, example. So let's just talk about example there. Let's suppose we are starting with this is a CH3. Okay, this is a CH and this is a OH and okay, two hydrogen is connected like this molecule we are having, and the same thing I'm adding, that is HiO4 is there. Okay, so in this case, how it is going to break, that this bond break. Okay, this is a normal simple two diol you are going to observe and then break in between the molecule. Okay, so then next one what we're getting, it's a CH3. Okay, it's a carbon and a OH. This one is basically going to add, that is a OH molecule. Okay, that OH molecule, I'm repeating one more time, OH. So if you have to break the bond, the previous OH is already there. The red one is this one OH added here plus that CH3 and one OH is added here. Okay, and hydrogen obviously the present here. I hope you already know. I already told you so many times on the same carbon, geminal diol never ever going to be the stable one. So they quickly form a water molecule like this. Right. Similarly, let me just write the OH be like this so that you are able to understand my point. That it's a OH and it's a hydrogen there. So basically, the water molecule quickly remove from there, and what you are getting there, that it's a CH3 and a COH. So what is it? It's our aldehyde. Similarly, you have to follow this molecule, and we are getting that aldehyde again, that acetaldehyde. Okay, this is the example number one. Let's see the example number two. So what is the example number two? What if let's suppose I'm using this kind of diol. Okay, let's suppose this kind of diol we are using. So same here, you have to quickly break and now simply do what? That break the bond and that directly connected oxygen there. So means again, if you have to break this, so CH3 maintain. Okay, and whatever with the oxygen there, quickly convert it to the double bond. That's it. Second one plus that again, look at this molecule only, that CH3 and hydrogen is the common point, and put oxygen there. So if you're observing something, this is my ketone and this is my aldehyde, so we can add up maybe both aldehyde, both ketone, or maybe one aldehyde or one ketone there. Okay, but as I already told you, in this case we are going to use only diol. But every time exception is always there. So generally we are requiring diol, but there's a one more exception for this molecule, that if let's suppose I'm having this alpha hydroxy alpha hydroxy carbonyl compound. So yes, again it is going to work. Okay, I'm repeating one more time, although diol is going to work. Okay, how much? Oh, I missed the timing. It's already 8. So what? Not an issue. Okay, Lakshmi. Not an issue. So look at this then. Which one, Mayank? Just let me know. Okay, I will stop then. Of course, Darshika. Okay, it's totally depend, like hydrogen, carbon, like obviously it's totally depend upon the thing. Okay, Vaibhav, okay, you are asking about the time. So maximum 1 घंटा, 1 घंटा 10 मिनट, 1 घंटा 5 मिनट और 1 घंटा 15, मैक्सिमम 15 तक जाती है, ठीक है। तो मतलब 8:30 तक कर देती हूँ, कई बार 8:15 तक भी हो जाती है, ठीक है। वैभव, ज्यादा नहीं लेती, ठीक है, 1 घंटा काफी हो जाते हैं। ओके देन, ओके मैम, थैंक यू सो मच देन, आई थॉट लाइक यू आर सेइंग डन, मयंक। अच्छा चलो, so let's continue again what we're discussing, that alpha hydroxycarbonyl compound. Let's check your basic knowledge, okay? So you have to tell me like which one is really alpha hydroxycarbonyl compound, okay? So I will give some option, let me know the answer, okay? So option number one, any general case you can say, okay? So wait, okay, so then what we're discussing, yeah, this is the case number one. Let me just write the carbon bill like this, okay? Why we have to separate this? Option number one, okay? Hmm. Yes, please. Which one is the correct answer here? Which one is alpha hydroxy? This one. Alpha hydroxy carbonyl compound. At least you have to identify. Okay. B. Okay. So not bad, very good everyone. So it's alpha, right? So first of all, I hope you know the rule that this is a carbon. If some functional group is connected there, so the carbon is going to be the alpha carbon. So in this case, the functional group is this. So definitely this carbon is not the alpha. B not, this is not the alpha carbon. Okay. So this is the functional group, 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 okay? So in this case, if you are observing this case, with respect to this is alpha carbon, with respect to this alpha carbon, with respect to this alpha carbon. So it means we are checking for alpha hydroxy, right? Hydroxy means OH group, it's nothing, just a simply the OH group is there. So look at this OH beta position, so it's a wrong there, alpha position right, like it's again alpha beta, or Even that is a gamma there. Again, it's wrong. Okay. So option B is the correct here. Okay, then so sorted. It means the next thing we are going to start that if you are having alpha hydroxy, sorry, if you are having a alpha hydroxy carbonyl compound, so then how to use this HIO for there? Okay, so you are having some R, okay, and this is H, and let's suppose this is some R des. Wait, okay, I have to use fairly. So R, OH, and a double bond and R des. Okay, so first let me just explain how to approach this, because what is the problem with this? Like sometime you are having a problem with the product. So again, look at this time we're not having diol. This and this carbon you have to mark the point number one, and then break again. Break the bond between OH and a carbon-carbon double bond, and then again you have to simply connect 2H 2H both side. Okay, 2H 2H both side. It's a trick. Okay, so let me just erase the bond between these two. Okay, like this. Don't worry, I will form one more time. Look at this. Okay, so let me just write this properly. What is it? It's a R C O O H is there. Again, if you're observing something, it's not stable, right? Again, if there's a 2H group is present, so quickly form a water molecule. And then what we are end up then, that once the water molecule release, we are getting that RCOH. So first one, aldehyde is formed. Second of what? That in this case, look at this portion. It's a R dash one. So R dash and a carbon double bond and OH is there. Okay. So this one. So if you are using alpha hydroxycarbonyl, one product is going to be the acid and one product is going to be the aldehyde or ketone. Okay, why I'm saying aldehyde or ketone? Wait, so like this is the common point. This is a acid in both the cases. Okay, and if you're observing something, this is the aldehyde here. Okay, let's see one more type example, and maybe you're getting my point then. Again, if you're using some R, and let's suppose some CH3 group is connected like this. Okay, let's suppose this is the question for you. Okay, and again, if you have to break the bond between them, like again. And okay, let's add some OH group, OH added here, and OH also added here. So what will be the final product? That are CH. And again OH and OH. Again, if the water molecule release, we are getting ketone there. Okay, so this is the ketone. And for this one, it is a CH3, CO, and OH is there. That's it. I hope it's clear now. Any problem with the recent HiO4? Now you will tell me. Okay, so I guess it's simple one. That's it. Now let's start with some preparations. Some naming reaction. Okay, so what is the good point in this carboxylic acid one? That if you are having a naming reaction, we are not going to follow any kind of mechanism. Mechanism is not really important here. Okay, so let's start with the separate class now. So oxidizing part is now covered there. Okay, you can use more oxidizing agent. If you remember, we just covered in the very first part. PCC you can use, CrO3 you can use, dry CrO3. Okay, or you can use copper as well. So or HiO4 is specially used for the diol kind of condition. And which diol? That is vicinal diol. So now let's start with the preparation of aldehyde, right? As I already told you, first of all, we are going to start with the ketone and aldehyde both, and then the second one, aldehyde only. So now we are going to discuss about that portion where we're discussing aldehyde only. Okay, so let's discuss about the preparation of aldehyde only. So in aldehyde only part, like which thing we can use? First of all, we are going to use the acid chloride. Every kind of substrate has a separate naming reaction. Like if I'm using acid chloride, so Rosenmund reaction. We're using nitrile there, so we are having a that is a Stephen reaction. So different reaction have to be there. Okay, so first of all, acid chloride. So in the acid chloride, let me just write all the step, right? So acid chloride, and the next one is water. That is a nitrile and esters, nitrile or ester, and the third one is the hydrocarbon. So let's start with the first one, that is acid chloride. And let's write the name of a reaction. It's really, really, really very much important reaction there. That is a Rosamond reaction. Rosenmund, okay, like Rosenmund reaction. So what is this Rosenmund reaction? Like in this case, first of all, make a kind of chart for every name reaction. First of all, substrate. Which kind of substrate we have to use in a Rosenmund reaction there? That is RCOCl. Or in short, this is known as a acyl chloride. Okay, acyl chloride. I said acyl chloride means acyl chloride. For a naming reaction, you can't change the substrate, you can't change the reagent, even you can't even change the condition as well. Substrate this is. Okay, so in this case, what is the reagent? How about the reagent? Like which kind of reagent we are using there? The reagent is what? H2PD and BSO4. Now, anyone, can you just tell me the name for this reagent? It's one of the famous reagent. Or you can use some sulfur or quinoline as well. Sulfur or a kind of quinoline. Lindar catalyst. Okay, so very good. And what is the use of this BSO4 here, or the quinoline here, or the sulfur here? Yes, it's a Lindlar catalyst. Okay, so if let's suppose I will give the name for this one. So it's a Lindlar catalyst. This one. Okay, let me just quickly give you a brief about this reason. What is the point? Let's suppose if you are starting with the carbon-carbon triple bond, and you know the famous one, that H2PD platinum platinum, that one if you're using here. What is the problem? That at the end you are getting a single bond. It means you can say alkyne system where end up. But if no, I want to stop the reaction till carbon carbon double bond only. So then in this stage we are using a special catalyst, that is H2. So do you know that platinum platinum single is like having a very strong catalytic effect. But we be like, you are very much active. Let me just give you a little bit kind of poison. So we are just poisoning the catalyst. We are just blocking some side of the catalyst, not like we are really using the kind of poison. So it's a kind of sheet there. First of all, you're having a platinum, then you have to spread little bit amount of charcoal or a carbon. Okay, and then there is some kind of surface present on the catalyst. Then you have to fill some gap, okay, with the sulfur. That sulfur block the that point there, okay, and that being like a simple, that is the poison. Okay, so you can use any sulfur. Quinoline. Okay, what is quinoline? Quinoline is a heterocyclic compound. If you don't know about the quinoline, it's like a two benzene connected with one another. Nitrogen is connected here. Okay, so this is a kind of quinoline, or any sulfur thing you can use there. Okay, so let's just back what we're discussing again. Substrate part is done. And what is the product? Yes, this is the second, like for every name reaction, which kind of question frame? Substrate for Rosamond reaction, a reason for Rosamond reaction, or the product? Definitely the aldehyde. Okay, aldehyde is the product there. Or sometime you are given some like substrate question mark, you know how to have the question frame from the different kind of reaction. So now this is all for the Rosamond reaction. Let me just write the general reaction for you, that what is Rosamond reaction there. So that you are using some R, CO and Cl, and we are using PD, BSO4 is there. Okay, what we are getting? We are getting aldehyde. It's a general reaction. And then have the example. Let's suppose some CHCO. Okay, same reagent and aldehyde. We are end up. Okay, so it's a normal Rosamond reaction. Okay, not an issue. Yes, you're right. So this is all for the case. And okay, now let's talk about the nitrile one. Theoretically, let me just quickly wrap up the part. Next one is what the nitrile one. So listen my point. It's really, really very much important part. if you are having a nitrile group, okay, if you are having a nitrile group, for example, nitrile be like the basic one, the famous one is what? Cyanide. Okay, in this case, this question asks so many times. That is the point number one. If in this case you have to undergo, that is a partial reduction. Partial reduction. So we are going to get amide. Every point is here very important, especially for the conversion part. But in this case, if you have to go with the fully hydrolysis, okay, okay, let me just write complete hydrolysis. Better to write partial hydrolysis. Okay, and in this case you can say complete hydrolysis. Don't worry, we will cover what is the meaning of partial and all this thing. Just for this point only I'm explaining. We are getting that as acid. So means if I'm having this RCN, is there any way to stop the reaction till aldehyde only? Okay, because maybe this product can be there, maybe this product can be there. So now main agenda is what? How to get this product, how to get the aldehyde. So let's start with this point here, that how to start or how to approach this. So first of all, the method number one, reduction part we are discussing now. Okay, reduction part. In the reduction part, if let's suppose I'm having this, any reducing agent, you want to suggest me that if you to follow the reduction, okay, let me just write H. I hope you know the meaning of reduction, right? Any kind of reducing agent, you know, if I want to stop the reaction till aldehyde only, because I guess you already know that is the reaction, it's like difficult task to stop the reaction till aldehyde. Reduction we're talking here. Yes, please. Any reagent? Let me tell you some. Chromium. No, 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 no. Divesh, listen, listen, listen. Make sure this point, make this point clear, everyone. That CrO3 is a oxidizing agent. Okay? So I guess your basic is like what you are doing. Let me tell you one thing. Let me tell you one thing clearly. What is really? First of all, oxidation. So what is the meaning of oxidation? Addition of oxygen, right? So means I am starting with some kind of alcohol, then we have to undergo the oxidation, then we are end up with like some kind of aldehyde, then further oxidation, so we are getting some kind of acid there. So it's oxidation. What are the oxidizing agent? Again, just make a kind of list or a chart for every oxidizing agent. So which was oxidizing agent? PCC. Okay, John's reagent or the chromium oxide H2SO41. Same, actually this is a John. Let me just remove this. Okay, or the chromium, dry chromium oxide. Okay, and the one of the famous one that are KMnO4 and the K2CR207. Okay, some more HiO3 we just discussed, we HiO4, or I guess main part is already covered. Okay, maybe I missed someone. Okay, osmium oxide, yes, OSO4. Okay, main these are the oxidizing agent. But let me just back again. See, I'm doing opposite. I'm having acid and I want like aldehyde or alcohol. So it's a reduction. And if I'm using the reducing or reduction part here, so what is the famous reducing agent? So again, make a kind of list that lithium aluminum hydroxide, famous one, or the NaBH4, that is a sodium borohydride, second of what, and a dibyl H, if you remember. Okay, so what is dibyl H? That diisopropyl, wait, diisobutyl aluminum hydride. Okay, dibyl H is there. Okay, or sometime you can use some kind of SN or HCl there. So this is a very good reducing agent. SN plus HCl. Stephen's reaction, if you remember from the which chapter. Okay, I don't know, but there's a some this reaction we already covered. Stephen's reaction, SNHCl. So these are the common reducing agent. If I said reducing agent, so the thing first you strike in everyone mind, lithium aluminum hydroxide one. Okay, you can use yes, Birch reduction as well. Okay, Birch reduction is also there. So like, please first make this point very clear. What is oxidation? What is reduction part? Okay, this one is the last one. Okay, is this point clear? Okay, now suggest me any reagent out of between lithium aluminum hydroxide and NaBH4 or dibyl H and SNHCl or batch reduction. Which one I have to use so that if I want to stop the reaction till aldehyde only? Wolf Kissner one. Which we can't use. Do you know what is Wolf-Kissner reaction? If let's suppose I'm having some RO, okay, it's not like I know the reduction and I can go, right? If you're having a carbon-carbon double bond, do you know what is Wolf-Kissner reaction? That this is simply adding hydrogen there, right? That just to remove the CO bond completely. So we can't use Wolf-Kissner reduction. Okay? So listen my point. Okay, I will give a hint and then let me know the answer. Lithium aluminum had as a four hydrogen. So you can say more is the hydrogen, more is the power there, right? So why not? Maybe I can replace some hydrogen with other groups. So maybe we're reducing the tendency, right? So yes, let's go for it. So now let's discuss about, see, it's clearly written here that diable H kind of thing. So anyway, let's discuss about the derivative of lithium, okay, or lithium aluminum hydroxide. So what is the problem? That if in the R, CO and OH is there, I'm directly using lithium aluminum hydride. So definitely at the end, I am going to end up with the alcohol is there. Point number one. So now we are going to discuss about a derivative of this. Okay, so what is the meaning of derivative? Derivative be like lithium is same, aluminum is same, but maybe we are changing the hydrogen with some other group there. So let's discuss about the derivative. It's not like I'm explaining just because I want to explain. No, important one. That's why I'm explaining. Okay, so let's discuss about the derivative. And like the naming reaction, that reagent is also important. First, let's just finish the syllabus. Then we are I'm going to conduct some classes only for reagent or only for the naming reaction, okay, so that we can revise simply. Derivative number one, that aluminium combined with O, C, and it's a tertiary butyl. It's a derivative number one, means every hydrogen simply replaced by that O tertiary butyl. I'm not saying that is a directly T. O is connected here. So again, that is O and a T, Bu there. And just because of hydrogen is also connected here, because we want at least one hydrogen. Why? Because obviously the reducing agent, at least one hydrogen we are requiring. So reducing agent, negative charge, if you don't know, maybe that is AlCl4, negative charge, it's boron family. B Bf4 if there. So every time negative charge, it's aluminium family, boron family. If you don't know, just be noted, aluminium got the negative charge because of the extra bond on the positive charge. Lithium will like am a counter and the derivative number one. Okay, so like how about the structure and all this thing? Let me just write in a bracket. It's a lithium, aluminium, that maximum most of the time. This is how the reagent written on the that line. Okay, so it's important. What we are basically doing, we are reducing the power of lithium aluminum hydroxide. If the same reagent in place of this lithium aluminum hydride, if I'm using this lithium Al HO tertiary butyl, so definitely the final answer is what? Aldehyde only. Okay, so it's important. Second derivative, this dibyl H. This dibyl H is the second derivative of this lithium aluminum hydride. So what is dibyl H? Aluminium. Okay, diiso. One carbon, two carbon, three carbon, four carbon. So what is it? Iso group. Y kind of group. I already told you, I guess, so many times. One more. Okay, so the name is what? Dibyl H. So di for two, right? That one this and one this. So it's become di. And iso group, four carbon. So it's become isobutyl. Isobutyl. So di for dibyl, I for iso, B for butyl. Aluminium for because aluminium is also there. And some hydrogen is also connected with the aluminium. So it's dibyl H. Okay, so it's a mild reducing agent. It's not that much strong like the aluminum. So the most of the time, the famous one which we're using every time is the dibel H. As compared to this weird one, it's hardly we are using, but most of the time dibel H we are using. Okay, so this is all for the derivative. So means what is the main point here? That if I'm using some kind of thing, let's start with some basic one. If I'm using RCO, it's one of the famous. If you remember the previous chapter, that it's famous for ester. That if you want to convert the ester into the aldehyde, so dibyl H is the very much important reason there. Or RCN. Even like what is the problem? If you to go with the reduction every time we either we end up with the amide or acid. But this is the only reason which do the reaction and stop the reaction till aldehyde. So for all three cases, if I have to use the dibyl H, so what we're getting? Aldehyde only. It's really, really, really much important reason. Like the PCC is famous for mild oxidizing agent. Similarly, the dibyl is famous for the that mild reducing agent. Okay, some reaction we also left, but that's it. This is enough for the class. Done from my side. Yeah, I know so many reactions, Shiva. You're right. Open ML that is for ester formation. Okay, I'm saying opposite. That if you're having ester and then you want this. Okay, Shiva. So done. Any more problem or any problem with the class if you are left? So please ask. And like, okay, welcome. And thank you so much everyone for joining the class. So like, what is the name? Dashika. So you want to discuss that doubt or shall we end or the doubt is already clear? It's hard to find your number. Yes, please. Still you are having a doubt. It's a dibel H. That is di isobutyl aluminium hydride. Okay, thank you so much, Jatin. I will tell you one more time. That is di isobutyl aluminium hydride. Wait, I will write D I B A H. Okay, this is how it's become dibel H. The same one you ask about, like how the pH changed, that question, Dishika. I guess that part is clear, the deposition one. Just please confirm so that otherwise we are going to end then. pH increase. The same question. Can you just resend one more time? Because right now I'm not having that pictures. Deposition is clear. So yes, let me know should I have to cover or not. If the part is already covered, then leave. Otherwise, I will explain the question. You know, in your group, there's just so many chats, so it's very hard to find something in the group. So please resend if you want to discuss. Otherwise, just confirm. I will end then. Okay. I got it. Okay, let me just write the question. If you want to understand, please stay here. So this is the question, okay? So you are having a CuSO4 solution. CuSO4 aqueous solution we are given is electrolyzed. Electrolyzed by PT electrode. Okay, after electrolysis, the question asks simply that what should be the correct answer? After electrolysis, the option number one, pH increases. Option number B, the pH decreases. Option number C, that is the pH is same. This is the question. Anyone you want to try? Yes, anyone? Do you know the answer or want to try? C, okay, pH is same. Okay, so anyway, I'm not assuming you're able to answer the question. Listen, actually, sorry. What is the question want to ask to you? You're having a copper sulfate aqueous solution, okay? And question is like electrolysis by platinum electrodes. So simply we are talking about here that is electrolysis. Electrolysis means that you are having a electrolytic shell. So what is the meaning of that? You are having electrolytic shell, that the shell, what is electrolytic shell, which convert the electrical energy into the chemical energy. Simple, sorted. Okay. So if I'm talking about the cathode and anode part here, so anode like left side, cathode means right side. Okay. And if we are using the charges there, so anode, which charge? Anyone? Which kind of charge on cathode and anode? So everyone be like C. Okay, not bad. At least you tried. It's charge on anode and cathode if it is electrolytic shell. Anode minus cathode plus. No, it's not electrochemical shell. It's electrolytic shell. Bharula, come on, right? What you are doing? It's a very basic question, okay? So, like plus. So, so you have to consider, ma'am, right? So be noted that cathode positive charge is only in electrochemical series. Sorry, electrochemical shell. Here my cathode is negatively charged, anode is positively charged. Done. Got it. Simple. That electrolytic shell when the current converted from electrical to the chemical energy. Now, point is what? That it means one thing is very clear that whether you can take electrolytic shell or electrolytic shell, anode every time oxidation. That only oxidation is going to occur on anode. And if I'm taking only the cathode part, so what is happening? Reduction. This is a fixed thing. Sign can be changed, anything can be changed, but it's a fixed point here. So cathode be like positive, cathode be like negatively charged, and anode is positively charged. So let's just back toward the question. Question said you are having CuSO for aqueous solution. CuSO for aqueous solution is there. Okay, so in this case, what is the important point there? That if you are using copper sulfate, so copper sulfate be like, if I have to break, I will give you the copper sulfate plus SO4 2 negative ion. Point number one. But diluted aqueous be like, no, come on, water is also present there. Water be like, why not my H positive and OH ion is there? So the question be like, should I have to, okay, anode be like, I'm having positive charge, cathode be like, I'm negative charge. So cathode is waiting that who is going to connect with me? I am negative and there's a two kind of ion present into the solution. That is the ion number one H positive, ion number 2 or the copper 2 positive. And now at this position, you will be having a very good knowledge of that deposition table. Okay, so it's like which ion we have to select or which one we are not going to select. So if we are checking for the deposition, yes. So if you don't know, let me just write the table for you, okay, and then answer the question. So for the cation one, what is the ease of potential? Order of ease of discharge of cation. Okay, this is the order of the discharge of the cation. I am just telling you like how to use the table. Okay, so then the first of all you will be having lithium, then you are having potassium, then it's going to be the calcium. Okay, can anyone tell me that why the lithium at the very end? It's not like I'm using just because I want. Sometime every time there is some kind of logic is there. Yes, please, anyone. Answer, what is the meaning of deposition or the discharge? Something is moving. So who's moving? The lighter is moving. Lithium be like, I'm small charge, I'm having more hydration, I'm having less mobility, right? Less mobility. No, 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 this is not the case. Come on, what we're doing, mobility one, right? But yes, you're right. A. Okay, so mobility. So lithium will like, remember, small is the size, more is the hydration, lesser will be the mobility. It's very hard for the iron to deposit it. So that's why lithium is the very end. Okay then, so what we are discussing, iron. No, if you don't know about this, who's saying like I thought it's we are using a table. No, 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 it's not that table. Okay, it's a different one. I already sent this on in the group. Please check it. That it's important. Be noted if you don't know about this. So it's a platinum, then H positive, and then copper. This is the same thing, just I want to highlight to you. Copper, Ab, and Hz. Okay, maybe you already know these things from the noble metal. So the Au and Hz and wait, okay, it's working. So look at this, the last three, like noble Au, Az, Hz, and copper. So like if you to little bit try to compare with the electrochemical series as well, hydrogen, that some metal combine with acid form H2 gas, but some don't. Like if let's suppose I'm having a copper sulfate solution, sorry, if I'm using copper, that is only the copper, and if I'm using some diluted acid, so what is happening, that no, there is a no formation of H2 gas. I guess it's a typical ninth or 10th class experiment. Zinc can do, but copper can't do, or Hz can't do, or Az can't do, or Au can't do there. So anyway, let's back to our question, that if you're observing the order, this is H positive and copper. You know what is the false hope for the student, that ma'am Grother Dapper mechanism we are going to follow, that jumping mechanism, if you remember. We used to think like H positive, the smaller one, it's going to follow every time the maximum value. The mobility I'm talking. Okay, if you don't know the Grother mechanism, if you remember that hydrogen H positive is going to jump, or OH is also going to jump. That's why they're having a high conductivity in the solutions. Okay, so let's back again are the question. So between copper and H positive, you will tell me that who's going to deposit it first? Is it copper or is it H positive one? Yes, yes. Actually, I'm taking some other doubt, like some personal doubt. Okay, if you are not having any problem with the organic chemistry session, so you can leave. Okay, but if you want to continue, you can continue here. Okay, copper is there, the shika, right? So you're just simply telling me the copper there. So between H positive and copper be like, I have to deposit it. So let's just back again the concept. Cathode be like, oh, copper. So cathode start eating the copper. If cathode start eating the copper in the solution, what is increasing? H positive concentration increasing, right, Dashika? Because two type of positive ion, so copper start depositing on the cathode, layer formation take place, H positive left into the solution. And you will tell me, if H positive maximum, so pH is what? Do you know, it's a question, it's a PYQ question. But the problem be like, maybe in the class we teach not consider this topic there, but it's really important topic. Yes, please. Decreasing. And then I guess you are getting your answer. Like why the answer for the question is option number B. Okay. So let me just back again. What should be the answer? Option number B. Okay, everyone. C is not the correct answer. Be noted. So like every time close your eyes and go for the hydrogen. But for copper or the silver or the platinum or like noble metal, they never ever going to participate in a reaction if H is there. Okay. No, H positive increases. H positive increasing, so pH decreases. Because you know the pH and H positive is in inversely proportional relation. So let me just explain this, that the pH is what? pH is equal to the minus of log of H positive ion. For example, if my pH concentration H positive concentration tan raised with the power minus 5, so my pH is going to be the plus 5. See the difference? It's minus 5 and it's a 5 there. So they're how much they're inverse to one another. Okay, Dishika. So if H positive concentration increasing, so pH decreases. The acid has a lowest pH because they are having more H positive ion. Okay, but if H positive decreasing, then pH increasing. Because apply the normal equilibrium concept, okay? Of course, this is the only way to approach these kind of questions, Disika. Okay, like maybe like let's suppose this question, let's suppose maybe in future this question in the exam, and some be like, ma'am, how to identify the pH because water is not given, copper sulfate, how it is connected with the pH, and then we are going to do what? Okay, this question is wrong. We want additional mark, right? But it's not incorrect question. It's correct question. Important is what? How to approach the question. So electrochemistry is easy. But the thing is what? How to approach the question is important. This is the problem with the chemical equilibrium in this chapter, especially. Okay, Dashika, I hope the doubt is clear now. Any more doubts? Otherwise, I guess it's okay. So let's add the class then. Thank you so much for your time. Thank you so much for joining the class and have a nice day. Okay. Thank you so much, everyone. No, Dashika. Okay, that's it. This is the series. Now, shortcut. What is the shortcut? If H positive is there, every time H positive. Okay, every time H positive. Make sure noble metal. If copper is there, Az is there, Au there, platinum is there. So then we can't go with H positive. Maybe some of you already saw some question from like some metal is there and question be like which one is going to deposit, which one is going to attack on cathode or anode. Some option like platinum, copper like this. Right, Dashika? So yeah, like I am not assuming like it's impossible to remember the complete series, but remember the main thing. We know copper is a noble metal. Okay, if you don't know the series, we can solve this just by logic only, Dashika. Okay then. So thank you finally. Thank you then. Let me just end the class then. Thank you.